out here on the shores of the Wailea River, and we're going to talk about both estimating and risk management. Now you may say, well, that's an odd combination, but it's really not, because in both of those areas and with those specialty techniques, what we're going to be talking about is the probability of various amounts of work and various amounts of cost. And we deal with that idea when we're doing our estimating on each achievement in our plan, and we also deal with it when we talk about how we avoid risk events, which can substantially increase the amount of work we have to do or the amount of cost we have to incur. So that's why we put them together, because the techniques are closely related, as you'll see. We'll start with estimating. Now, most people use start and finish dates when they build their schedule, and that is Bush League rookie techniques. You do not want your project managers, and you don't want to use on a program level, just start and stop dates. Why? Because if you and I agree on an estimate of my start and finish dates, and I tell you I'm going to be finished by the 30th of June, when are you going to find out whether I'm going to finish on time? On the 30th of June, right? On the other hand, if you and I agree that my task is going to be 120 hours worth of work, and the first week I come back and tell you I got 20 hours done, and I've got 100 hours remaining, well, you know a couple of things. One, the original estimate of 120 hours is still good. But I only got 20 hours worth of work done this week, not the 40 that was scheduled. And so you know you have a problem in the first week instead of waiting until the team member tells you about it on the planned finish date. That's why people who manage projects for money or programs or portfolios for their living use work estimates. And it's because it mainly gives us early warning on problems, so we can solve small problems early rather than big problems when it's too late. Make sense? The other things about using work is we are clearly separating what we're holding our team member accountable for versus what's out of their control, and how much time their boss lets them work on the project is out of their control. So we manage the work. There's a lot of science and statistics we can apply to those estimates. And so getting your whole project manager group converted to estimating work is an early first step that you have to accomplish. Every professional firm in the world estimates work for their projects because they have no other way to control things. So we have to have the estimating be work-based. Now, when we do our estimates, we're not just looking for good numbers. We want those. But we're also using this process to start building our team and the project team culture, and to start getting some commitment from people to those estimates. So the best process here, the best practice, is that our estimating process involves our team members. They're having a hand, they're having a say in the estimates. And if I get a little bit of commitment from them out of this process, I've made a good start to developing a team that thinks I'm going to manage them fairly and that their assignments are reasonable. This is in contrast to a team that starts work on a project knowing they will fail because the work estimates are unrealistic and unreasonable. So I always want to engage as many of the project team as I can find, as I know about at this time, and involve them in the estimating process. And we'll talk about as much about the numbers as we talk about the commitment process, because we need both out of this. Now, for working with our team members, we're going to use 3 estimating techniques. There's some other estimating techniques we'll talk about later for the whole project. But when we're down working with team members, we want your project managers working with them either with swag estimates or parametric estimates or PERT, 3 techniques. Swag estimate is the simplest. We would use that with an experienced team member in a very casual way. They're still involved, but we're just taking a swag, someone's wild-ass guess. And we're sitting down maybe over a quick cup of coffee. Hey, how long do you think that's going to take? Maybe 2 days. All right, break it down a little bit for me. One day meeting with the managers, one day putting together the document and get their approval in the afternoon. Say fine. 16 hours of work, and we have a swag estimate. We've done not much work, but we have engaged the team member in setting that number. They feel it's their number. It wasn't crammed down their throat. Second technique, not as good for commitment, frankly, as the swag estimate, but it's the parametric estimate or production standard. And that's where we go back to data from previous projects, and we say, well, okay, we've framed an office like this before. Let's look at the last 3 times we did it and how much work it took. Or let's look at this GUI computer data entry screen we're designing for our people, and we've got a couple that are similar. Let's see how much work they took. So we're looking at our history, again, working with the team members, showing them the numbers. Here's how long Jim took it when he did it 2 months ago. And we're using the historical data or a parametric rate that we find in a estimating book to calculate the amount of work. And it may be on a per unit basis, on a per square footage, or on a number of data fields that we have on the data entry screen, on the GUI. But we're using historical data as the basis for the estimate, but we still want our team member to agree that the work estimate is reasonable. Our most powerful estimating technique is PERT, P-E-R-T, Program Evaluation and Review Technique. There's a whole diagramming method that we're actually using in Microsoft Project that's a PERT chart. But what we're going to talk about is in the PERT estimating is where the team member or team members make 3 estimates. One is optimistic. That's on, if everything goes really well, how quickly they can do it, how much work, again, not duration. There's a best guess, which is sort of half the time it'll take more than the best guess, half the time it'll take less. And the pessimistic estimate, which is where some things go wrong. And there are instructions about how you detailed those numbers to your team members, but they come up with 3 numbers, and so they might have something like a best guess estimate of 100 hours, an optimistic estimate of 80 hours, and a pessimistic estimate of 150 hours. Notice that the pessimistic is further from the best guess than the optimistic is, and that's the way the world works. The consequences of the bad stuff that can happen to us are much more significant than the benefits of the good things that can happen. We're never going to get this 100-hour task done in 1 hour. But we very easily could take 200 hours to do it. So we have a little bit of what's called kurtosis, or it's not a smooth bell curve kind of distribution, and that's fine. We want people to think about what factors will make the job take longer, take more work, and include that in their estimate. So we have SWAG, production standards or parametric estimates, or PERT estimates. You'll get a chance to do all 3 of these in the assignment. And that's the way we work with our team members to develop the estimate and get their commitment to those estimates. Another technique that we use is analogous estimating. And that's where we take data from, again, a previous project. Could be the whole project, or it could be just a phase. It might even be a task in that project. And we are talking to our team about how our task is different from that historical one. And we come up with an adjustment factor. We say our current project is going to be 20% more work than the historical one. And so we take the data from the previous project, increase it by 20%, and that's our analogous estimate. As you'll do in the assignment, we can do this for each of the major phases of a project. Find a similar scope for that phase, do an analogous estimate, do the multiplication. Could be more, could be less work than the previous project, and that's how we build the analogous estimate of the project as a whole. And you may even use this on individual tasks when you can't find something that is real close to this task that you've done previously. That's analogous estimating. On all of these estimating techniques, particularly the SWAG and the parametric estimates and the analogous estimates, we have to have historical data. And that's why the number 2 thing after you convert all your project managers over to estimating work is you set them up to start archiving historical data about every project when we finish it, so that we have this data to go look at, to use for the parametric, even SWAG estimates, and certainly analogous estimates, and we use our historical experience, what actually happened, and that's much better than relearning painful lessons project after project after project. So historical data is really the key to good estimating. And when you look at organizations that do it well, they have a very strong, usually database of tasks and how much work they took, and you can pull those up and look at them for all of these estimating techniques that we're talking about. Now, if we don't have any historical data, like if it's real early in your tenure as the portfolio manager, if it's 5 years after you took over, shame on you. If we don't have any historical data and we have to build it from scratch, we probably would use the PERT technique, and we'd get a little fancier with it in the sense of having a meeting with people who've done this kind of thing before and ask them to start off by developing a list of the pessimistic factors, the things that could go wrong on this assignment and cause it to take more work. And then we'd ask that same group to make a list of the things that could go right on the project, the optimistic factors, and make a list of those. And then we ask everybody to look through the pessimistic factors and use that as the basis for their pessimistic estimates, and the same with the optimistic. And then in the best guess, we're talking about being in the middle. We have maybe a little bit of the optimistic factors, some of the pessimistic, and we make our best guess estimate. And that's how we use the collective experience of our team members, or even people borrowed from outside the project, to develop the PERT estimates that we're going to use ongoing. The powerful part of using PERT estimating for your techniques is that after we have the 3 estimates, we can use the formulas you're going to see on the slides to calculate a mean and a standard deviation. And then we can use that and some standardized statistics to calculate things like, what work number do I have to estimate to be 80% sure of finishing in that much work or less? And we can use that kind of statistic to give our project sponsors a sense of the risk in each task. And when they say to us, I want to be 100% certain we finish this on time, we say to them, well, that's going to take a very high work estimate because we've got to cover a lot of the tail end of the curve, but you can actually give them data. And here's the estimate, and here's the duration of the project when we're 60% certain of finishing on time versus 70% versus 80 versus 90. And with the PERT numbers, you have all the data to make those estimates. In fact, we'll give you a spreadsheet on how to do that. Your template actually has that. That you can put the PERT numbers in and calculate the amount of work you need for various levels of probability of finishing on time. And that is very good data to be able to discuss with a sponsor, because they like talking about probabilities. Their favorite is 100%, but you'll quickly see that to get to 100% certainty, that's impossible. To get to 99.9% certainty of finishing on time, you may have to have 5 times the best guess estimate. So it's good to educate sponsors to that risk-reward combination, and PERT lets us do that. Now let's move into risk management, although really we've been talking about that all along, haven't we? And we've been talking about the probability of various work amounts on a task and measuring the risk that way. But that whole focus has sort of been down on the project team and on the amount of work they have to do. Now we want to talk about the risk of things that could increase the amount of work or the cost of the project that happen outside the project team, external factors, factors from the organization we're performing the project in. And that's the kind of risk management we're going to do. And I would suggest that you do at least some risk management on every project, no matter how small. It's worth 5 minutes of discussion over coffee to identify the principal risks, even if the project's going to be done in 2 weeks. So we always do this because this is how we avoid problems. And there are too many organizations where executives want project managers who are good firefighters. And we think we need to make the case that the methodology you're using lets people avoid the fires in the first place. And that's far better than being good at putting them out. So let's talk about the techniques we're going to go through in the risk management process. Okay, the first step in risk management, and we always take this step, we just spend various amounts of time on it. And we might say for a small project that has a duration of less than 3 weeks, our risk management process in its entirety is going to be 1 hour. And we're going to spend 10 minutes on risk identification, and that's where we're going to sit around maybe with the project team, maybe the team and the sponsor and some of the more significant stakeholders and say, let's spend 10 minutes and talk about the risks this project faces that could cause us to take a great deal more time or spend a great deal more money, and because we want to identify those risks now. We're not talking about what we can do about them. We don't want to try and judge the significance. We're just looking for a laundry list, 10 minutes worth on a small project, of the risks that we face. And remember, we're not only talking about bad things, but things that could happen, risk events that could cause this project to take a lot less work. We want to consider both sides of that coin and simply identify those items. Now, on a bigger project, we're going to increase the amount of time. You may have more people involved and more stakeholders. You may ask certain of your significant stakeholders to be on the risk management committee. If it's a big project, it's going to take a year, is a strategic initiative for the organization, it's worth having a more formal risk process. And we'll talk about how you scale the risk management effort to the size of the project. But the basic idea of coming up with a list of identified risks, both positive and negative, is true whether you're over 10 minutes of coffee or have a 2-day off-site meeting to talk about risk identification. Our second step, and again, we take this step no matter how big or small the project, is qualitative risk analysis. And here we're not working with any hard data. We're just taking that list of identified risks and, again, reaching consensus with our group. It could be with our team, could be you and a sponsor. Does this particular risk have a high, medium, or low probability of occurring? And then, what's the magnitude going to be if it does occur? Is that going to be high, medium, or low? This is not fancy statistical stuff. It's qualitative, but we're using these two measures, the probability or the likelihood and the magnitude or severity of the risk, and using just high, medium, and low, and going through that list of risk events and sort of slotting each one of them. And what we probably wind up with on a small project is we're not going to do anything more with a risk that doesn't have a high probability of occurring and a high magnitude of its impact if it does occur. And those few that are rated that highly we'll go on and plan risk responses for. But the qualitative risk assessment, whether on a small project or on a very, very big one, is simply to let our experts, the people who know the most about this, judge the various risks so we can sort them out and figure out which ones we're actually going to spend some time and money to avoid. Now, we have two ways that we can go after qualitative risk analysis. Most of the time, we're going to go straight to our risk response planning. What the heck are we going to do about these risks we've identified as most significant? On a really big project, and if you have some of the technical skills you're going to use in this course, if you have some risks that really have a frighteningly significant impact on the project, we're going to do some quantitative risk analysis. And there, instead of using that high, medium, and low probability, we're going to use an actual probability. This has a 0.33% chance, or a 33% chance of occurring on this project, and the impact is 200 days added to the duration, or the impact is $45,000 added to the cost of the project. So we have a number for both the probability and the magnitude of the impact, and we'll do some exercises with that, actually calculating that magnitude. The way we do that is we simply multiply the probability, the 33% I was talking about, by the $100,000 impact on the project, and so we say that risk has an expected value of $33,000. 33% times $100,000 bucks. And that $33,000 is a very important number, because we absolutely do not want to spend any more than that to avoid this risk, because this expected value is only $33,000, so spending $50,000, we're wasting money. And in fact, we only want to spend anywhere near to $33,000 if we can totally make that risk go away. If all we can do is reduce its likelihood, then we're probably not going to spend more than maybe $15,000 to do that, because we still have a significant amount of risk that is left after our mitigation action. So that's how we use the data out of quantitative risk analysis, and it's to justify more expensive risk responses, which is a nice segue into, let's go talk about our risk response planning. Okay, we've gotten to the last step in the risk management process, and that is risk response planning. What we're going to do here is lay down, here are the most significant risks, here's what we want to do about it, here's the impact on the duration of the project and the cost to take this risk response actions. Now, there are a couple of kinds. One is we can use risk avoidance, and that's where we redesign the project to get rid of the risk. If, as an example, we're real concerned about our database analyst or our concrete engineer quitting and moving out of state in the middle of the project, well, one of the ways we might avoid that risk is to hire that specialty in-house instead of contracting outside for it. And that redesign would avoid the risk in its entirety. So that's our first strategy, is to redesign the project to get rid of the event that is causing the risk. Our second risk response strategy is to insure against the risk. And what I mean by that is that we buy insurance to cover ourselves so the risk doesn't affect the project. Let me give you an example. If we're concerned about turnover among our database analysts or our structural engineers, we might avoid the risk by contracting for those skills with an agency, with engineering firms as an example, who guarantee to provide us the skills even if they have to go out and hire additional people. So we're paying them a form of insurance to be sure we have those skills available to the project when we need them. So that's another way we try and avoid the risk by redesign. We can insure against the risk by shuffling the risk off onto somebody else, and that usually costs us money. But we have to evaluate the cost of contracting out for it, as an example, versus the expected value of the risk. That's our second strategy. Okay, our last couple of risk responses are risk mitigation, where we do things to lower the probability of the risk or lower the magnitude if it does occur. And that's mitigation. So we might do things, as an example, if we're concerned about people quitting mid-project, we might pay them or offer them a project completion bonus if they stay through the whole project. So we spend a little bit of money, and reduce the probability of them leaving mid-project. And that would be a mitigation action. So we've got our redesign, we've got our contracting out or insuring the risk, we've got our mitigation efforts, and last of all, with the rest of the risk, we may simply accept it and develop a contingency plan of covering what we'll do if the risk does indeed occur. Let's go ahead and apply this stuff on the exercises and give you a chance to practice it.